Okay, now we'll start with the part number 2 of the week 1 lecture, and we're going to go through the contents of this lecture as following. So the topic we're going to cover right now is going to be about the engineering design, and we're going to go through the engineering design process in general. Then we're going to talk about the computer-aided engineering and the computer-aided design, and then we're going to come to a brief description about the Industry 4 and the advanced manufacturing. We'll start with the engineering design process. So first, let's define the good design. The good design is a process that creates a functional and visually appealing solution that meets the specific purpose. It involves a carefully considering elements like the color, the layout, the typography, and the imagery of the product at the end. On the other side, the bad design is considered to be a design that lacks of the clarity, the usability, and the functionality, often failing to meet the user needs by being confusing, frustrating, into interact with the visually unappealing or inaccessible, usually due to the poor layout, inconsistent element, or the discrete for the user experience principles. So, as you are the designer, you need to first ask yourself a set of questions like who the customer for the product I'm about to design, and also what kind of technical preparation will you need to complete the design. Also, what the steps will you follow, and what information you need, and how will you show by calculation that the design is safe and is that the product will perform its design function. So the ultimate objective of engineering design is to produce a useful product that satisfies the needs from the customer and that is safe, efficient, reliable, economical, and practical to manufacture. So if we show that as a schematic diagram, you can see that the requirement development is going to be the first point. You need to recognize the need, identify the problem, define the requirement, then you are going to provide the conceptual design. We're mainly going to generate the innovative concepts and select the best concept of that. Then, of course, you can send the feedback to the requirement developments in case if you would like to change some of these concept design. Then you go to the detailed design where you're going to have some main final product layout, the material selection, the system simulation, the prototype and the testing, and the design documentation. Then you're going to start with the production stage where you're going to decide what the type of the manufacturing, the production volume, and the supplier selection. All these stages going to send a feedback to the one before and the main one to update the requirement of each stage that you have done before. After you finish everything, you can go to the final product. And once again, the final product can be tested by the customer and you can send a survey to check the requirements has been updated or the functions has been satisfied. So again, how we can say that the design is good. So it's good if meets all the technical requirements, work all the time, that's very important, meets the cost requirement, requires a little or no maintenance, it is safe, creates no ethical dilemmas, and finally is still good. Bad if basically the opposite of all the above has been found. So have you made your targets? That's your set for yourself. If you are going to meet your targets, that's when you're going to have a good design. So design is what the engineers do. What make a good engineer? First, you should have the good knowledge, the skills, the intuitions, the interpersonal skills, and the drive and determination. So design is usually going to be conducted in a team. So design criteria for the designer is going to be about the safety, the security, reliability, being cool, and whatever you can add to the products to look better. So the designer is a knight in a box constrained by a limits. You cannot dream. You should always keep your dream within a limit of possibilities. So some evaluation criteria, we're going to start with the safety. Of course, we're going to have the performance, the ease of manufacturing, and other steps. So for example, we're going to start with design a car. So design and the work, as you can see in 1961, they need to build, after they're doing the engineering drawings, they need to build a small prototype to a certain scale where they can do some testing on it. Like, for example, they didn't have the CFD or computer-aided design at that time, so they have to do something like the wind tunnel testing to check, for example, what will be the flow over the car, to check the resistance factor and other stuff. So the major step will include, first you have the concept sketch, scale model creation, prototype development, the computer-aided design, the computer modeling, powertrain engineering, and manufacturing process. So for the present and future car technology, as you can see in the case of the Ferrari that we can see in front of us, the Ferrari will go like the wind. That's the promise. Okay, so something like from 0 to 100 kilometer per hour time in less than 3 seconds, and it's almost as fast as a Formula One race car. So the car in the future should be green and intelligent vehicles, should have advanced control, energy sources, energy saver, and you have to have a new material or a special material to make them lighter and more durable at the same time. So skills needed in engineering design for advanced manufacturing, mechanical and mechatronic and robotics will include the sketching, technical drawings, and the computer-aided design. This should be a must for every engineer to learn. Second, you should have a good knowledge about the properties of the materials processing, and manufacturing processes. Also, a good background about the application of the chemistry, like the corrosion protection, plating, and painting. The statics, dynamics, strength of the materials, and the kinematics of the mechanism are very important issues that you need to learn to have a good design. The good designer should have a good oral communication, good listening ability, and technical writing and teamwork skills. A knowledge in the fluid dynamics, thermodynamics, and the heat transfers are must. The fluid power, the fundamental of the electrical phenomena and industrial control. Experimental design and performance testing of the materials and the mechanical systems. Creativity, problem solving, and the project management. Stress analysis. And finally, specialized knowledge in the behavior of the machine elements. So you can use the American Unified Standards, which been done by the American Society of the Mechanical Engineering. You can check their website. And by the way, as a student, you can get a free membership with them. And also you can use the Australian and New Zealand standards. For example, you can use the Australian and New Zealand standard 2451 for 1998 for the bolts, screws, and the nuts with the British standard with wetwood thread for the rationalized series. Also, you can use the Australian Engineering Drawing Handbook from 1993. So I told you that back in the old day, they didn't have the computer-aided design or aided engineering, which is a new concept. We know it mainly as the CAE. So the computer-aided engineering is the performance of the engineering's tasks and functions with the aid of the computer. So these tasks are still administrated and controlled by the engineer. The CAE is well-established field, but it has been poorly formalized and very fragmented. The CAE will cover the computer-aided design, the computer-aided analysis, the computer-integrated manufacturing, and the computer-aided manufacturing, material requirements and planning, and computer-aided planning, also known as the CAP. So why we need the computer-aided engineering? The computer-aided engineering techniques provide the means to cope with the demands of the increased productivity of more sophisticated and reliable products design and manufacture. The needs is for the good system design, efficient and reliable hardware, and effective usable software. In the computer-aided engineering, the data can flow electronically between the departments and the whole operations can be monitored and controlled. The computer extends the designer capabilities, like organizing and handling the time-consuming operations, repetitive operations, and they analyze complex problems. We will go through the product development of one of the products like the Invisalign. So in the image A, you can see an example of the aligner, and in the B, a compression of the conventional orthodontic braces and the transparent aligner compression. So I think that many of you saw friends or family members using the transparent one, which can do the same work as the old one that using the wires that need to be uh, fixed from time to time, and it was have some hygiene problems. So the process used in the application of the Invisalign orthodontic treatment, where first the impressions are made of the patient teeth by the orthodontist itself, and then it's going to be shipped to online technology, and these are going to be used to make the placer models of the patient teeth. High-resolution 3D representation of the teeth are produced from the plaster models, and the correction plan is then going to be developed using the computer tools. Then the next step is going to be a rapid prototype molds of the teeth at incremental position are going to be produced through a stereolithography process, which is a type of the additive manufacturing processing, or what you know it in general, 3D printing. And a liner produced by the molding a transparent plastic over the stereolithography part, and the patient is going to be left with the healthy bite and a beautiful smile. Now, the other technology is a computer-aided design, or known as a CAD. And I think that many of you have learned what the terms of the CAD mean. Computer-aided design, or the CAD, is use of the computer to display a design, accept any changes to them, and calculate and display the results. The CAD has many different applications, which include the designing of new cars, the bridge and the building design and testing, the printed circuit boards design, designing of new aircraft, and the designing of the fitted kitchens. So the computer-aided design and the computer-aided engineering and the computer-aided manufacturing are three terms for a different technology that all using the computer to do the work. So the computer-aided manufacturing is something also we learned about of running the different functions of the manufacturing with the aid of the computer itself. So the computer-aided design processes are going to be, for example, have two types of the activities, the synthesis and the analysis. The synthesis is largely qualitative and hard to capture on computer, and the analysis can be greatly enhanced with the computers. And once the analysis is going to be complete, the design evaluation can be done by using the rapid prototyping. Also, a software package for design optimization can be also applied. Now, the last section of today's record is going to be about the Industry 4 and the advanced manufacturing. So, how we got the term of the Industry 4. The Industrial Revolution and the future review that we had is going to explain the term. So the first industrial revolution was using the steam power to do the manufacturing. And that's happening in the 18th century. In the 19th century, we start to use the massive production assembly lines requiring the labor and the electrical energy has been introduced. And in 20th century, well, actually, the industry too was from the 19th century to the mid of the 20th century. And the Industry 3 started when we start to apply the automated production using the electronic and the IT, like the using of the robotics and the automated systems like the CNC. The Industry 4 nowadays is about using the intelligent production incorporated with the IoT, which is Internet of the Things, and the cloud technology and the big data processes. So the Industry 4 and the advanced manufacturing is a current trend of the automation and the data exchange in the manufacturing technologies is by using the cyber physical system or the Internet of the Things or the cloud computing, all of them. So the creation of the smart factory. So within a modular structure, smart factories, a cyber physical systems are going to monitor the physical processes, create a virtual copy of the physical world, and make the decentralized decisions. Over the Internet of the Thing, the cyber physical systems communicate and cooperate with each other and with the human in real time. And via the Internet of the Services, both the internal and the cross-organizational services are going to be offered and used by the participants of the value chain. So the affecting all the elements of the value when we're going to use the Internet of the Thing and the Industry 4, because we're going to have the end-to-end digital engineering. It's going to be a link to the Internet of the Thing enabled manufacturing and Internet of the Thing service implementation and the Internet of the Thing service operations. So this will be definitely working with the other side about the sales and the marketing and the business model, the enhancing of the work environment, the adaptive logistics, and the aftermarket services. So all the things are going to be all connected by using the Internet of the Thing. We can use the AI, which I think that you know what the term is. The AI, the AR, and the VR also can be applied in the Industry 4. So we can check about what we have in the real world, like the components, the machine, and the production. We can add the cyber physical interference process by applying the data, by having the data collection, use the knowledge base and the data-driven models and the physical models to make a comparison. And we're going to have the organization and the data harmonizations and the analysis. You can have the visual synthesis and the visual components, the virtual components and virtual machines and virtual productions. Send the information to the cloud computing in the cyber world, which can be actually shared with the other similar activities. So in review, we had the general introduction to the unit today. We had the mechanical system design and system engineering, and we talked about the Industry 4 and the advanced manufacturing. You can have a look to the lecture and tutorial and practice notes we're going to cover over the week. And also again to have the face-to-face session where we can actually cover more material, and we're going to be happy to answer your question about the topic that we covered in this video. Okay, so next week we're going to have a lecture, tutorial, and a computer lab about the parts and assemblies and the drawings. We're also going to have a video for that, and the reading is going to be about lecture slide tutorials and the practice notes. Thank you very much for your attention, and see you soon.